Saxon Algebra 1, Lesson 25. We study solutions of equations. In the previous two lessons, we introduced two rules for solving equations. They are the most important rules in algebra, and we repeat them here. Rule number 1, the same quantity can be added to both sides of an equation without changing the solutions to that equation. That's called the addition rule. Rule number 2, every term on both sides of an equation can be multiplied or divided by the same non-zero quantity without changing the solutions to that equation. We call this the multiplication or division rule. In many equations, it is necessary to use both of these rules to find the solution. We will always use the addition rule first, and then the multiplication-division rule. We use these rules in this order because we are undoing a normal order of operations problem. To demonstrate, suppose we begin with the number 4. We multiply it by 3, and then add -2. This gives us 10. Now, to undo what we have done and get back to 4, we must undo the addition of -2 first. We do that by adding +2. And that leaves us 4 times 3 equals 12. And then undo the multiplication by 3. We can do that by dividing 3. The 3's cancel on the left. And so we end up with 4 equals 4. This example shows why we must reverse the normal order of operations when we solve equations. That is, we must undo addition first, and then undo multiplication or division. Let us rework the undoing part of the previous example with x in place of 4. We start with 3x minus 2 equals 10. We want to isolate x. First, we undo the -2 by adding +2 to both sides. That leaves us with 3x equals 12. Then we undo the multiplication by 3 by dividing by 3. The 3's cancel on the left, and we're left with x equals 4. Let's look at some more examples. Suppose we want to solve 4x plus 5 equals 17. The first thing we notice is the equal sign, and we identify the left side, which contains the x, and the right side, which is 17. X is multiplied by 4, and 5 is added. We must undo the addition of 5 first, and we do that by adding -5. If we add -5 to the left, we must also add it to the right. And that leaves us 4x on the left and 12 on the right. Then we need to undo the multiplication by 4. We can undo that multiplication if we divide by 4. So we divide both sides by 4. The 4's cancel on the left. And finally, we're left with x equals 3. Let's look at another example. To solve negative 5m plus 6 equals 8, again we pay attention to the equal sign. We identify the left and right sides. The m is on the left. M is multiplied by negative 5 and then 6 is added. We will undo the addition of 6 first. We add negative 6 to both sides. And that leaves us with negative 5m equals 2. Now negative numbers can be a little confusing, so we will change the negative 5m to positive 5m by simply multiplying both sides by negative 1. Then we have 5m equals negative 2. Now we undo multiplication by 5. We divide by 5. The 5's cancel on the left, and we're left with m equals negative 2/5. Another example. Negative 7k minus 4 equals negative 21. We add 4 to both sides to undo the negative 4. And that leaves us with negative 7k equals negative 17. We will change negative 7k to positive 7k by multiplying it by negative 1. But we must multiply both sides. And that gives us 7k equals 17. Now we can undo the multiplication by dividing by 7. And the 7's cancel on the left, and we're left with k equals 17/7. We will leave the fraction as an improper fraction. Another example. 1/5 m minus 1/2 equals 3/4. We will undo the addition of negative 1/2 by adding positive 1/2. And that leaves us with 1/5 m equals 5/4. To undo the multiplication by 1/5, we will multiply both sides by the reciprocal of 1/5, which is 5/1. Then the 5's cancel on the left, and we're left with m equals 25/4. Again, we will leave the fraction as an improper fraction. Here's an example involving decimal numbers. We treat it the same way. We want x by itself, so we need to undo the subtraction of 0.2. Therefore, we add 0.2 to both sides, and we get 0.4x is positive 0.04. To get rid of the 0.4 in front of x, we divide by 0.4. And that gives us x equals 0.1. Let's look at one last example. Here we have 17 equals 7 minus 2x. Now the x is on the right side. So look closely at the sides of this equation. We want to get rid of the 7 and the negative 2 in front of x. We'd better rewrite that right-hand side as an addition problem so that we can handle it correctly. It's actually 7 plus negative 2x, so the 7 is being added. Therefore, we add the opposite of 7 to both sides, and that gives us 10 equals negative 2x. We will divide by negative 2 to get x by itself. That cancels the negative 2's, and we are left with negative 5 equals x, or x equals negative 5. A riddle. I am thinking of a number. If you multiply the number by 2 and then add 7, you get 91. What number am I thinking of? Let's call that number x. We multiply it by 2, and we add 7, and this gives us 91. Let's see what happened. The last thing we did was to add the 7. So we will undo the adding 7 by subtracting 7 on the left side and on the right side. That leaves us x times 2 equals 84. The first thing we did was to multiply the number by 2, so we will undo that part by dividing both sides by 2. So the answer to the riddle is 42. This is the end of Lesson 25. Your assignment, problem set 25 on pages 108 and 109 of your book.